Okay, so three main things about our trial runs. First one is that the robot never moves out of the starting zone. Second one is that the arrows do not go anywhere near as far as they need to. And then the linkage shoots the basketballs out way too hard and it's not very good.
Okay, so I'm going to talk about the code side of things. So I'm going to share my screen regarding the code. So right here we have our code. So the main things were that our archery worked. So we fired the pneumatic piston both times, and it worked. While not well, the code actually ran as intended. And for the basketball, our linkage assembly, so the piston actually opened and closed as intended. The only thing is that the code is designed for a momentary switch. So during the actual competition, we had to press the push button twice for the code to actually run and not keep running and looping. So that was the only thing that we need to fix in our code, and the rest actually ran pretty well.
This is the part of our code that looks at the motor and the motor movement. This part of the code needs to be updated and reflected in the next sprint. This code wasn't used originally because we were having trouble with calibrating how far the robot was actually moving and moving backwards. And then here, if we actually look at our 3D SolidWorks part, the gear is not very stable, and we were having issues with the gear switching on us and moving the robot either too far to the left or right, and then not moving that same way when returning. So that will be another issue that will be tested and tweaked as we move forward with our design.
So in addition to that, as Jacob mentioned, the archery task was probably one of the biggest issues we had. We just weren't getting enough force out of our pistons to launch the arrows. And so we've got two main ideas for moving forward with those, shown in the model right here, and I'll show a mock-up that I've built in just a second. Is a rubber band crossbow that'll be released via either pneumatic piston or arrow or motor, pardon. Or another design that we're considering replacing it with right now is just simply releasing the pressurized air from the pneumatic system directly onto the ping pong ball to launch that forward. You can see here's a mock-up of how that system will look if we decide to go with the crossbow system. Rubber bands hook onto here to an axle rod, pull back, and launch arrows.
From the video, we can see our current problem with the linkage that the pneumatic piston pushed the linkage and the PVC pipe up there too hard. So the two basketballs were delivered with poor accuracy. Our plan is to replace the pneumatic piston with a motor plus a gear and rack system, so the PVC pipe can be delivered more stably and the basketball can have a higher accuracy.
The next part for our design is including our lever action pickup for the money ball. Because the robot did not move, we did not have to try and enact this function at all during our sprint one. However, as we need to score more points, we need to complete more functions and complete more functions successfully. And this is at the top of our priorities. To talk about scoring more points, here's Steven.
Yeah. So over the course of our 3 trials in sprint 1, our team scored 280 points out of the available 390. We in the first test scored 1 basketball into one of the red cups, and got all balls past the scoring lines. And we deployed successfully and recovered successfully. In the second trial, I believe we recovered successfully, deployed successfully, and got 3 out of 4 balls past the scoring lines. And in the third trial, we got all 4 balls past the scoring line and 1 basketball into an orange cup. So hopefully we can start going for more consistent balls and cups in the future, and then by the time we roll around to getting past sprint 2 and into the final stretch, we can start looking at getting closer and closer to the center of each point array.